If you're running a machine shop, maybe managing a manufacturing floor, or perhaps you're just about to sign that PO for your next big machine, you're probably at a bit of a crossroads.
A really high stakes one, actually.
Yeah, you're facing that fundamental choice, the one that's going to shape your labor costs, your profitability, really for the next, 10 years? Are you going vertical or are you going horizontal?
Exactly. This is the classic VMC versus HMC debate. Vertical machining center, horizontal machining center. And look, the difference isn't just, how the spindle sits.
No.
No, it's much deeper. It's about whether your machine is actually spending its time making chips or just making money, choosing the wrong one. It's not just a bad buy.
It's a strategic mistake, isn't it?
Totally. It limits your shop's ability to grow, to automate, and ultimately to win those really high-margin jobs.
Right. So we've dug through a whole pile of sources today: machining efficiency, manufacturing strategy, and our mission here is pretty straightforward. Cut through the confusion, the jargon, and give you the framework you actually need.
Yeah, we want to help you make the right strategic investment decision.
We're going beyond just speeds and feeds here. We're talking ROI, labor efficiency, the whole picture.
Okay, so let's start with maybe a quick blunt summary. If your shop is mostly doing, say, flat parts, plates, maybe molds, prototypes, or, smaller batch runs, the VMC is probably your go-to.
It's a versatile workhorse, right?
Yeah.
Affordable. It's often the first machine a shop buys.
Exactly. But, and this is the crucial, but the minute your parts get more complex, boxy shapes, needing work on multiple sides,
Or the volume ramps up.
or your volume demands real consistency and speed, then the HMC starts looking less like a luxury and more like a necessity. They are absolutely purpose-built for high-volume, automated production. Think complex parts needing multiple faces machined.
Okay, so that brings us straight to the cost, because HMCs are, well, they're not cheap.
No, definitely not. It's a significant capital outlay. You look at the same basic work envelope, same horsepower. You can probably expect an HMC to be, 30%, maybe even 50% more expensive than the equivalent VMC.
Wow. Okay.
But, and here's the key, that sticker price, it can be deceptive. If you match that HMC investment to the right kind of work.
High volume, multi-sided stuff.
Precisely, that machine can slash your man hours and cycle times so dramatically. Its ROI can blow the VMC out of the water. It's really an investment in cutting down labor costs.
Okay, let's really unpack that core difference then. It seems so simple on the surface, right? Vertical spindle versus horizontal. Why does just changing the orientation have such a fundamental impact on what the machine can do strategically?
It really comes down to physics and accessibility. The spindle orientation dictates how the tool meets the part, how the cutting forces behave, and maybe most importantly, how many times an operator has to physically touch that piece of metal.
Okay, let's start with the VMC. Spindle's vertical, right? Perpendicular to the table. Tool comes down from the top.
Exactly. And as an operator, that feels really intuitive. It's almost like a super heavy-duty drill press. You've got great visibility, looking right down onto the cutting action.
Easy to see what's happening.
Very easy. And that top-down approach, it's perfect for easy setups. You load a flat plate, clamp it down, hit cycle start. The cutting forces go straight down into the table base, the most rigid part. So VMCs are great for, simpler geometries, big molds, dies, anything where most of the work is on one main face.
Okay, makes sense.
Yeah.
Now flip that spindle sideways. The HMC spindle's horizontal, parallel to the floor. Tool comes in from the side. My first thought is, like you said, visibility must be tougher.
It absolutely is. Visibility is sacrifice, no question. But you trade that for a huge strategic advantage. Access.
Access.
Yeah, access. The horizontal spindle works together with a usually very sophisticated rotating B-axis table. So instead of just hitting the top surface...
Like the VMC.
Right. The HMC can get at the front, the back, the top, and the bottom of a cube-shaped part, all potentially in one setup.
Ah, okay. So the whole design philosophy of the HMC is about minimizing how much a person has to handle the part.
Exactly. Think about machining, say, a complex hydraulic manifold. On a VMC, the operator might have to unclamp it, flip it, refixture it, find zero again. Maybe 3 or 4 times just to get all the sides.
Time-consuming and introduces errors.
Loads of time. And yeah, every reclamp is a chance for tolerance stacking errors. The HMC, it just rotates the table. 4-size machine, potentially, in one single clamping.
Okay, that makes perfect sense. And that reliance on automation, eliminating those manual steps, that takes us right into the ROI discussion. This is where shops really make or break it, isn't it?
It really is. We hear it constantly. A typical VMC might only be actually cutting metal maybe 25% of the time, the other 75%. It's setup, part loading, inspection, just sitting idle.
That's a staggering number when you think about it. 75% idle time.
It's the Achilles heel, really, if you're trying to do high-volume work on a VMC. That spindle downtime is just pure, unrecoverable cost. And the HMC, it's specifically engineered to attack that uptime problem.
How about the mechanisms?
Primarily, it's through its unique fixturing approach and usually a pallet system.
Okay, tell me more about the fixturing. You mentioned the rotating B-axis, but how do they actually hold these complex parts?
Right, so they often use something called a tombstone fixture. Picture a big, heavy, upright tower that bolts onto that rotating B-axis table.
Okay, like a block standing up.
Exactly. And because it's standing up, it typically has 4 vertical faces you can mount parts onto. So you can strategically load multiple parts, sometimes dozens, all over this tombstone.
Ah, so instead of one part getting worked on, you load maybe, I don't know, 10, 20 parts?
Or more. And the machine can cycle through them, hitting 4 sides of each boxy part without ever stopping for someone to manually flip anything over.
That alone sounds like a massive efficiency gain. But you mentioned pallets. That's the next level.
That's the true productivity multiplier. The automatic pallet changer, or APC. This is often what really justifies the HMC's higher price.
Okay, how does the APC work?
It lets the operator safely load up a second tombstone, let's call it pallet B, with fresh raw material, completely outside the machine's work area.
While the first one, pallet A, is inside being machined.
Precisely. The spindle is busy cutting on pallet A. Then, when pallet A is finished,
The machine just swaps them.
yeah, it performs this really fast, highly choreographed pallet swap, takes just seconds, and bam, it immediately starts cutting on the fresh parts on pallet B. The operator unloads finished parts from pallet A and reloads it while B is running.
Continuous production.
Continuous, minimal interruption. This is how you get spindle uptime numbers exceeding 85%. That's the key to lights out manufacturing.
Let's pause on that real-world impact you mentioned for the sources, because this is critical for anyone thinking about labor strategy. The aerospace example. Complex titanium parts.
Yeah, that was a great case study. They basically cut the required man-hours per part from 4.5 hours.
4.5 hours.
Down to just 1.8 hours, simply by switching to an HMC and really leveraging that automation, the tombstone, the pallet changer.
That's more than cutting it in half.
It's a huge reduction. From 4.5 hours of direct human attention per part down to 1.8. That's not just efficiency, that's transformative for the business.
How so?
Well, suddenly you're competing on cost and delivery time in a completely different league. And it frees up your highly skilled machinists from just loading and unloading.
Tedious work.
Right. And lets them focus on higher value stuff like programming, process improvement, quality control. It's a better use of skilled labor.
Okay, so automation is huge.
Yeah.
But beyond that, there's a physical difference too, right? You often hear about rigidity. HMCs are generally built heavier.
They are, yeah, significantly so, typically. Okay. It kind of goes back to the design requirements.
How?
Well, a VMC mostly relies on the table moving in X and Y with gravity working downwards. An HMC, because it needs to accurately rotate and position that heavy tombstone fixture, which is cantilevered out.
Right, hanging off the side.
It just needs a much heavier, stiffer frame to handle those forces without deflection. The mass is often lower to the ground too, which naturally dampens vibration better.
Okay, so more mass, more rigidity. What does that actually mean when the tool hits the metal? Is it just overkill if I'm cutting aluminum all day?
Well, if you're only cutting soft aluminum sheets, maybe it is a bit overkill. But rigidity becomes absolutely critical when you start pushing the limits.
Like with tougher materials.
Exactly. Or aggressive cuts. That rigidity allows for much deeper holes, faster feed rates, higher material removal rates, or MRR, even in tricky stuff like stainless, titanium, big cast iron blocks.
Less chatter, better finish.
Less chatter, definitely better finishes, and crucially, shorter cycle times, because you can push the tools harder without them vibrating or breaking. You make parts faster.
Okay, that makes sense. So rigidity isn't just about brute strength, it's about stability, enabling speed and unattended reliability. And that reliability point brings us to something else, often overlooked but apparently critical. Chip evacuation.
Ah, yes, chips. The bane of unattended machining. This detail is surprisingly important, especially for those lights-out shifts.
What's the problem on a VMC?
Think about milling a deep pocket or a complex cavity on a VMC. Where do the chips go?
Straight down. They pile up in the bottom of the pocket.
Right. They just sit there. And then the tool comes back around.
It starts cutting the chips it already made.
Exactly. It's called recutting chips. And it's terrible for the process. It generates a massive amount of unnecessary heat right at the cutting edge.
Which dulls the tool super fast.
Drastically shortens tool life, leads to unpredictable tool wear. And it can completely ruin the surface finish of your part as those chips get dragged around. It's a fundamental risk to process reliability.
Okay, but the HMC design, being horizontal, that helps here. How?
It flips the problem into an advantage, basically thanks to gravity. Because the spindle is horizontal, the chips naturally want to fall down and away from the cutting zone.
Out of the way of the tool.
Correct. They fall onto sloped internal machine covers, which are constantly being flushed with coolant. The chips get washed away immediately into a chip conveyor. The cutting zone stays much cleaner.
So the tool is always cutting fresh material, not grinding through old debris.
Pretty much. It makes a huge difference.
So better chip control isn't just about tidiness. It translates directly to the bottom line, right?
Yeah.
What are the main benefits we see?
Okay, 4 key things. First, and maybe the most obvious, is tool life. By preventing that chip recutting, your expensive cutting tools stay sharper, way longer. That cuts tooling costs and reduces downtime for tool changes.
Makes sense. What's second?
Second, improved surface finish. Significantly better. No chips getting trapped and dragged across the surface, scratching or marring it. Less rework needed.
Okay, those are direct cutting benefits, and the other two are more strategic, related to automation.
Absolutely. Third is process reliability. This is huge for lights out. You have to trust that the machine can run for hours unattended without a chip jam causing a tool breakage or scrapping a part. The HMC's chip management provides that trust.
You can walk away with more confidence.
Much more. And fourth, connecting back to rigidity, because the machine is both rigid and keeps the cut clean, you can consistently run those more aggressive cuts. Higher MRR, shorter cycle times, without worrying about stability or chip buildup. It's a synergistic effect.
That really shifts the perspective, doesn't it? You stop asking, can this machine make my part? And start asking, can this machine make thousands of my parts unattended, reliably, at the lowest possible cost?
That's the strategic mindset exactly, and it leads perfectly into the pre-purchase checklist. You absolutely have to think like a business strategist here, not just a machinist buying equipment, to avoid that awful buyer's remorse. It's about the long-term ROI.
Okay, let's walk through it. First, questions about your actual parts. We've got 3 key areas here. Number 1, complexity. Are they basically flat plates, or are they more like boxy shapes needing 4, 5, even 6 sides machined?
Right. If you're making things like transmission housings, complex valve bodies, manifolds, aerospace structures, the VMC with all its setups becomes a real bottleneck.
A liability, even.
It can be. The HMC, with its single setup, multi-side access, becomes almost mandatory for efficiency on those parts.
Okay, second question about parts. Material. Are you cutting mostly easy stuff, or are you regularly tackling big chunks of stainless steel, titanium, maybe large cast iron castings where you're hogging out a lot of material?
Yeah, if you're removing serious amounts of tough material, you're going to lean heavily on that HMC rigidity we talked about. It lets you push harder, get the job done faster, without excessive tool wear or vibration issues.
Yeah, makes sense. And third, for parts, tolerances. How tight do they need to be, especially across features on different sides of the part?
If you're holding really tight tolerances, the HMC helps immensely by eliminating those refixturing steps. Every time you reclamp, you introduce potential error. The HMC's one-and-done setup minimizes tolerance stacking, making complex, high-precision parts more achievable more reliably.
Okay, that covers the parts. Now let's pivot to volume and your current shop efficiency. This is where the labor cost calculation really comes in first. Batch size.
Critical question. Are you doing mostly one-offs, prototypes, very small runs? Or are you looking at stable, recurring production jobs, hundreds, thousands of the same part, maybe running for months or years?
And the HMC doesn't make sense for one-offs.
Not really. Its productivity advantage comes from setup reduction and automation over volume. It's kind of wasted on single pieces. But if you have that steady, recurring volume, the HMC's automation and uptime will crush the VMC on cost per part. You need volume to justify the capital.
Okay. And the other efficiency question, maybe the most important one we discussed, spindle uptime. You need to honestly assess, are your current machines sitting idle more than, say, 50% of the time, just waiting for an operator?
Waiting for loading, unloading, refixturing, resetting. If the answer is yes, that means you're paying skilled labor primarily to babysit expensive equipment that isn't making money.
That right there is probably the single most compelling argument for considering a pallet-changing HMC, isn't it?
It's huge. It directly addresses that wasted labor cost and machine time.
All right, finally, let's look beyond today's work. Questions about your business goals, your future strategy. First, labor strategy. Do you need to enable lights out or minimally attended operations? Maybe to compete globally or just deal with labor shortages?
If reducing reliance on operators for repetitive loading, unloading tasks is a key goal, if you want machines running overnight or through weekends, then the HMC with its automation is really the only viable path for complex parts.
Okay, a practical point next. Floor space. These things aren't small, especially with pallet pools. Definitely not. HMCs, particularly with APCs and maybe extra pallet stations or tombstone loading areas, take up significantly more floor space than a comparable VMC. You absolutely need to confirm you have the physical room to support the whole automated system.
Good practical check. And the last one, the big strategic question, future growth. Are you buying a machine just for the work you have now? Maybe comfortable, lower margin stuff.
Or are you investing in the capability that will allow you to win the more complex, higher margin contracts you want to have in the future?
Investing ahead of the curve. Exactly. If scaling your business, moving up the value chain, tackling more complex work is part of the plan, you really need to be thinking horizontally. The HMC often unlocks that potential.
Okay, so pulling all this together, it seems the choice becomes much clearer when you stop just looking at the machine and start looking hard at the work and your goals.
Absolutely. The VMC, it remains the undisputed champ for versatility, great for prototypes, tool room work, job shops doing small batches, anything where operator visibility and setup simplicity are really key.
Affordable entry point, flexible.
Yeah, for sure. But the HMC emerges as the clear strategic choice when you're dealing with multi-sided complex parts and volume, when consistency matters, when efficiency, process reliability, and especially maximizing that spindle uptime, when those become the driving metrics for success.
It's the automation and production powerhouse.
That's a perfect way to put it.
For everyone listening, maybe the takeaway here is to apply this kind of ROI thinking that's focused on automation and setup production, not just to machine tools, but maybe across your entire business.
Yeah, that's a great point. Look for any process anywhere in your operation where high labor costs or inefficient manual changeovers are acting as a bottleneck, just throttling your growth. Think about the orientation of that problem. How can you automate it, streamline it?
Reduce that non-value added time.
Exactly.
All right, and that brings us to our final provocative thought for you to chew on after this deep dive.
Okay, let's hear it.
The most expensive machine tool you can own. It isn't necessarily the one with the biggest price tag up front.
Interesting. So what is it?
It's the one that silently costs you productivity day after day. The one that keeps your skilled labor busy watching it not run. So when you really sit down and calculate the true long-term labor cost of operating a machine with only 25 or 30% spindle uptime,
Yeah.
does that initial saving on the seemingly cheaper machine ever really pay off in the long run?
That's the million-dollar question, isn't it? Something every shop owner needs to seriously consider.